Yesterday I was.
Okay, well, keep working on that one then. Pilot, was there anyone, one of the PAs here on Friday? Did they come and see? It wasn't? Okay, so they should be here then to start with lunch. Okay, what we started looking at last time was kind of basically the back end of enterprise systems. It's all database driven for the most part. So we've got hopefully a MySQL server now running in the background for you. I hope everybody's got that up and installed and ready to go. What we're going to now look at is how do you connect to it. Your applications actually have to get to the database. Essentially that means they have to speak SQL. So again, how you do that, how the application speaks SQL to the database will be dependent somewhat on the technology you're using. So we're going to start out here focusing still using Java technology, but as we move to PHP and other things, we'll of course upgrade how we actually do that. But with Java, it's through what's called JDBC, and originally that was called Java Database Connectivity. Since Sun kind of took things over, now officially that's not an acronym, it's just JDBC. Actually what it is it's about a couple dozen packages that provide all of the access to relational databases. We're dealing, of course, with relational databases in the form of SQL databases. There are other variants of databases, but for the most part, the commercial world certainly is, it's all relationally oriented. When we start talking a little bit more with the cloud and big data, we may deal a little bit with NoSQL databases, which are not strictly relational in the sense that they're not normalized, but they're often organized still as relational tables. So a lot will carry over from what we're doing even into NoSQL type database. JDBC is probably the most important part in it is the driver. Connecting to the driver basically is what the database vendor provides you and allows the direct control of SQL statements. So here's kind of just a brief summary of how JDBC developed. It used to be separately packaged from Java. You had to bring in a whole bunch of different classes if you wanted to use it. It's now natively bundled and it's all incorporated, so you don't have to do anything different with your Java environment to be able to access the JDBC components of it. The way it essentially works is we're going to kind of start out looking at what are called two-tier architectures. And in a two-tier environment, your client is considered a fat client, meaning that the client has to have the application on board for the user to be able to deal with your application. It's not server hosted. It's locally hosted on the client's machine. When we move to 3 and N-tier architectures, that application will move off into a server or the cloud, and the client simply accesses that environment and to get to it. But with 2-tier, you're essentially, your application is talking directly to the database, so you are the client of the database when you're using it in that sort of a form. The best way to get JDBC working, of course, is to get a driver from your database vendor. So when I was showing you how to get MySQL downloaded, I told you to be sure to get the connector J. That's the Java database connector that MySQL provides you. If you don't have that, which sometimes you don't, if a brand new database vendor comes out and they release their database, but they don't yet have all the connectivity available, you can use a more generic connector called ODBC, which stands for Open Database Connect. It has a couple extra steps in it that you have to go through to get the connection. It's not as efficient in that respect, but it will get you there. We won't really look at ODBC because, again, it's for the most part, you're not going to do any kind of enterprise solutions using ODBC. So there are a number of different types of drivers. The ones that are important to us, the ones from an enterprise point of view, are the native protocol pure Java drivers, the type 4 that you see there. And this basically provides a direct connection from the Java environment to the database with no in-between things needing to happen. Depending on the kind of database you're connecting to, the format for the driver and the format for the database URL is a little different. We're going to be using MySQL, so these two types of statements here you're going to see over and over and over in our code. But if you connect to an Oracle database or if you connect to an IBM DB2 database, that format changes a little bit. And later on in the semester, when we are doing things more in the cloud, we will set up some different types of databases that are available to you in the cloud, so you'll need to see those, use those different kinds of formats. But for right now, the only one that's going to make any difference to us is are these two here at the top. You're going to, like I said, you're going to see this over and over and over. So here's really what kind of happens when you need to make a connection to a database from a Java application. The application, the Java application, basically has to load the driver, load the database driver. The way this is done in Java is there's a what's called a driver manager. It basically is responsible for handling all of the drivers that you might need for any sort of connectivity to external applications. Essentially what happens is your application asks the driver manager to make a connection to a particular database. So that format that it's looking for essentially is telling the driver manager what kind of driver does it need to look and see if it can load. If it doesn't have that driver, then it's going to, of course, give you some sort of an error saying, I can't find the driver to load for this particular kind of application you're asking for. So assuming that the driver is there and everything, the driver manager basically takes over and establishes the connection with the database. So there can be again, lots of different drivers out there. You ask for a connection to a MySQL one. The driver manager realizes that format, makes the connection for you, for your application, and then in the end, the last thing that basically happens is the connection that is established by the driver manager is handed to the application and says, here's your connection, so you're ready to go at this point. Once that's done, the application is connected to the database and the driver manager is essentially now out of the picture. There's nothing really more for it to do. So getting that connection is really the main aspect of what the driver and driver manager is all about. So that first step, and I'm going to put this all together in a little example in just a minute. I'm just going to show you the sequence of what you have to do. And you're going to see this over and over and over. You've got to load the driver. Okay, so the way that's done is with a Java statement that looks like this. And then again, in the quotes here, you simply put the driver class that you want to load. What actually happens is you're not really creating an instance of that driver class. All you're doing is loading the class. So there's a static driver, static initializer that's basically run that loads the class and registers the driver. And that's basically where most of the work is being done for you, is loading of that driver. Now to do this, again, remember, you have to have that connector. For MySQL, it's the connector J. If you attempt to load the driver, as you attempt to make a connection, you don't have that driver loaded, you're going to get a Java exception. It's going to be a class not found exception. And the idea is it's not finding the driver class. So to avoid that exception, you've got to have that driver already installed in the right place. So when you downloaded the connector J, what it did for you in your MySQL environment, there'll be two different MySQL folders you'll find. You'll find one in program files and one in program files x86. In the program files x86, you'll find a MySQL folder that will inside there have a connector J folder. Open up that folder and you will find the this file here, the MySQL connector Java 5.1.36 bin jar file. You need to take that file, copy that file out of that location in the MySQL folder, and you need to put it into your Java environment. Now, where it goes in your Java environment depends a lot on the way you have your Java installed. Most of you, I think from what I've seen, are probably using Eclipse. Eclipse generally only needs a JRE to run. It does not need a full JDK. Not sure whether net means full JDK or just JRE, but you can cover yourself. Take that jar file and put it into your JRE library extension folder. Okay. You can also put it into your JDK JRE library extension folder if you're not sure whether your IDE is running from a JDK or JRE. Okay. So you can put it both places, it won't hurt, but it has to be inside the Java environment. Just having it brought down from MySQL is not enough. Okay, so when you put that into that library extension folder, then at that point, you're ready for Java to actually find the class and not throw this exception in. The second step in what's happening there is you have to get the connection. So you basically load the driver, and then you tell the driver, I want a connection to this database. There are, when you're getting connection, you have to specify the URL. Okay, that's the database URL. The optional parameters are the username and the password for who the connection is being established. You know, right now we're going to start things fairly simple. We're going to basically get a connection as an administrator, root user. So we're going to put the root user's name and password in here automatically. When we move to more robust applications, the decision as to whether it's the client connecting to the database or whether it's our application connecting to the database and passing through credentials is something we'll have to talk about. But in general, we're not going to give the client a direct connection to the database. It's going to come through our application, and therefore we can limit their capabilities. Okay? But they can't do everything on the database. But for right now, we'll put the root user's name and password in here, but keep in mind that those are optional parameters. So you can get a connection and then yet still have to pass credentials up to the database to actually allow a login on that server. Once that's done, then basically again what MySQL is doing, it's doing connection pooling. So it has a bunch of threads sitting there. Some applications, some Java applications now ask for a connection to the database. So what it does is it simply goes to the pool, grabs a thread, says, here's your connection. You're now ready to go on this particular connection. At that point, your application can now start to talk back and forth to the database until you decide to connect. To talk to the database from a Java environment, you have to create an object, a statement object, that you want to send to the database, and it will be an SQL statement. So you have to, on your connection object, create a statement. Okay. Now the statements are kind of general. We'll talk more about them as we go further along. But a statement is the way you send a message or a query or whatever it is you're doing to the database on the connection that you've established. So in general, the statement is kind of a generic, but there can be prepared statements, and there can be callable statements, and then of course there can be lots of metadata associated with that as well. A prepared statement is one where the application is just providing the parameters to the input. You're not typing an SQL query or insert statement, you're just giving it data. I mean, the application in the background is putting that data into the actual query or update that's going across, and the user doesn't even see that. The statement one is the one that's more general, and the user can create any kind of an SQL statement they want. A callable statement, which we will use later, is it's more like a remote procedure. The database itself can store queries and any kind of routine you want on the database itself. It's already generally compiled and optimized and so on, and your client simply asks for that to be run. So you're not actually sending an SQL statement, you're saying run this thing that already exists on the database. So you have a lot of options as to how you're going to talk to the database, basically. These last two we'll talk about more later, but this is on the transactional side of the database as to whether or not you want to commit the changes. Once a commit is done, as far as the database is concerned, changes cannot be undone. Rollback means that something went wrong, I'm going to undo what I did, and I roll back and basically leave the database in unchanged state. So once you create that statement, and you send your command, whatever it might be, to the database is going to send you back a response, the result. So again, this is just a normal, request response type mechanism that the internet is pretty much built around. So you've sent your command through the statement, and now you're waiting for the result coming back. So you have a result object that you're going to deal with on the Java side. Again, we'll talk a lot about result sets in more detail later on, but when you think about a result set, what can the database send you back? When you think about a MySQL database, think about some of those commands we were looking at the other day. If I send a query to the database, what, in general, what am I expecting back? A table. Yeah. A result of table set of data. It might just send me back a single attribute, a single number. It might send me back nothing. I sent a query up that had no results that matched, and it says nothing satisfied with the query. On the other hand, suppose I send an insert up to the database. What am I going to get back from MySQL on an insert command? Just to confirm, I'm always going to give an integer. The integer will tell me the number of rows that got inserted into the database. If I send up an update to the command to the database, say update this table such and such, what it's going to send me back again will in general be an integer. How many rows were updated? It may also send me back a result of just true or false. I did it or I didn't do it. On a callable statement, if this remote procedure worked, I get a true. If it didn't, I get a false back. So the point being, what comes back in the result set can be quite varied. Okay? It's not always just a table of data. So we're going to look at this. Like I said, we'll break this down a little bit more later. But if you want to execute a query, you have to use the JDBC execute query method. Okay? It is the only SQL statement that uses the JDB statement execute query. All other DDL, DML commands, inserts, updates, deletes, all those kind of things execute and update. Okay? And then if you are executing, like I say, a remote procedure, the JDBC statement that you use is simply execute. And the parameter to the execute then is the name of the remote procedure that you're going to invoke. So, quick and dirty, that's kind of the steps that you have to do. So I'm going to put this together all in one, this is about as simple a JDBC application as you'll ever see. I built that little byte database. I put that script out on web courses for you. So hopefully you've got MySQL up and running. You actually generated that little database. If you haven't done that, do that. And then you can run this application. Okay? So here's the application. Again, if you look through this, you want to see those common features that you're going to see over and over. Here's where we're loading the driver. Okay? Again, that class.4 name, and this is the specification. It always looks identical for any MySQL database. The next thing is we have to get a connection on that particular, from that particular driver, and we have to specify, again, several things. The main thing we have to specify is that we want a connection to this byte database, and this is the full URL for that. Okay? And then again, I'm passing through the root user's name and password in this case. Once that's done, I need to create the statement object so I can send some kind of command to the database. So I've done that right here. And then once I send that statement across, I need to specify my user query or whatever. So on the statement in this case, I'm going to execute a query. And I just hard-coded the query right here. I want to select these three fields from this table, and it will be in this database. Okay? I've already got a connection to that database, so I don't need to specify the database at this point. I just need to specify the table in that database. And those are the three attributes I want. What's going to come back at this point is a result set. Okay? So that's the answer to my query, basically, is in this result set object here. Now, when the result set is a table, it's basically just like a two-dimensional array. You can iterate through it and treat things in it just like a two-dimensional array. We'll get more sophisticated in our handling of that later on. But for right now, you can see what I do here is I just grab, as long as there's something left in the result set, I just grab what's there and I just grab the strings. Okay? I know what they are because I told it in the query the 3 fields I want. So I already know what those attribute names are. So I just grab those and then I print this basically out and iterate through until it's all done. Last thing is to simply be correct and close the connection object because we're done with the database at this point. And I put some extra stuff in here just printing out things so you can kind of see what was happening as it went along. And then this is what you see. When this executes in a Java environment, you can see the driver gets loaded, the connection is established. Again, if you don't have your connector jar file in the right place, Java can't find the driver, it's at that point right there where you will get the class not found exception. It would go in the same place. Either the JDK or JRE library extension of your NetBeans is directed to. Again, you can set up, I know I haven't done very much with NetBeans, but I know with Eclipse and NetBeans, you can generally set them up so that they're running either through a JDK or a JRE. You just have to find out which one of yours is set up. And like I say, if you don't want to dig in and find out, just dump them in both places. You should be good. So you can see then, in this case, there's a lot of extra stuff. I just printed out the connector so it tells me what actual version I loaded from the connector file. And then here is where it actually gets into the result set and just iterates those 3 fields out of each record from that database, and we're done. Okay, so that is again it's about as simple as a JDBC application as you're going to get, straightforward connection, and then a simple query, and then just iterating through the results set. We will get much more sophisticated with that as we go along. Particularly, we'll talk about different types of connections. This connection that we're dealing with here, when we make this connection, is essentially a static connection. It's going to stay connected to that database on that URL until we close it here at the bottom. But we can have connections that come and go. Again, databases generally have a lot of activity on them. The connection pool there is, of course, to make rapid assignment of connections. And if you have an application where you're going to download some data and then do a lot of processing, and a little bit later you go back and download some more data, do a lot of processing, it's more efficient if you unconnect or disconnect from the database while you're doing it. There's no reason to tie up the connection to the database while you're not doing anything with the database. So we'll deal with some of those things as we get more into the enterprise side of things as we go along. But the next thing you want to look at are result sets, because you want to be able to get very sophisticated with dealing with your result set. You also want to, in this case here, I did not do anything on the database side with the metadata. Okay. All I did was get back straight results from the actual database. Metadata, when you took your database course, did they talk about metadata very much? Some yes, some no. Well, metadata is just data about data. And what it basically is from a database point of view, it's the data dictionary. So here, for example, when we created this table, this byte database, we have the byte name, the cost, and the mileage. Those are 3 attributes. There are several other attributes in that table. Each of the attributes has a type, a field width. Some of them are designated as key. All these kind of things. These are basically things about the attributes, or it's describing the data in the table. I did not do anything with that here. But I can also extract metadata. I can ask the database about the data it's sending me. And one of the things I'm very commonly going to want to ask is, what is the attribute name? Because I want to display it. Because you notice here, I didn't display the name of the attributes here. That's, from the point of view of this application, it's very simplistic. But also now, what does this number mean when you're looking at this table? Unless you remember that it's the cost of the byte, It's just a number, it doesn't have any context. And similarly, this is the mileage on the bike, but you don't see that in your result here. I should actually extract that metadata and put it here. So as we start dealing with the result sets actually split into two pieces. There is a result set of data, and there's also a result set of metadata.
So what's the name of the driver we have to download? MySQL JConnect?
The connector J is what you get from MySQL. Inside that folder, when you install your MySQL, it creates two folders in both program files and program files x86. In the program files one, that's where you're going to find the MySQL system. In the program files x86, there's going to be a whole bunch of other folders, including the workbench and so on. But connector J will be a folder in there. Open up that folder. There's going to be 4 or 5 different files in there. The only thing you need is the Java.
And then that's what we use for our
That's what you copy over into your Java. Okay, so the result sets, we have normal kind of data coming back from them. They're basically just two-dimensional arrays, and you iterate through them in a lot of different ways. So essentially what the iterators that are doing on the result set is there's a whole bunch of getter methods for all of the different kinds of data types that are supported in the MySQL environment. And again, Java is an object-oriented language, so it deals with its own types as its inherent built-in types and then as its object types. MySQL as a database has its own built-in types, and they're not necessarily directly compatible across the board with Java. So one of the things, for example, that you'll get in MySQL results will be dates, times. They represent them differently than Java. There's also what's called a blob object, which is a binary large object. It could be an image file, an audio file, whatever it might be. That can also be retrieved, and you can deal with it again on the result set side. You can also deal with just a generic object coming back. So all these different types basically have getter methods, and you just have to kind of look through the Java documentation to see the whole list. It's quite extensive based on what MySQL has available. But when you get a result set back, there's a lot of things you can and can't do with the result set depending on the kind of result set you have. By default, a result set is not updatable, and it only has a cursor that allows you to move forward, not move backwards in the result set. You can also change that. You can make the results scrollable, and you can make them updatable. This is where, again, you have to be very aware of what your application is doing as far as the database is concerned. One thing that's very dangerous is to make the result set updatable. In other words, I get a set of data. I'm looking at it on my screen like you have here. And I just decide to go in and change this number right here, say from 8,000 to 10,000. Okay. What happens on the database side when that gets done? Well, when you think about what happened on the database side when it was put in initially, there are probably all sorts of integrity constraints that are built when the creator of the table specified that particular action. Maybe they said that no bike's going to cost more than $10,000. So if I now go in and put that at $10,000, that would actually violate the integrity constraint that says this attribute shouldn't have that value. But my Java application isn't the database. It doesn't look at that integrity constraint. It just stores it. So many times these updates that you can make on the table could violate integrity constraints in the database. They're not checked on an upload, re-upload of the table. So you have to be aware of what those are and not allow those kind of things to occur. That, of course, puts a little bit more work on the Java developer to make sure that you understand those constraints. Also, when you think about certain kinds of, when you did your database course, you dealt with joins, tables, you get results, say the result of 2 tables being joined together. Well, when you do the join of a table, you often join on common attributes. But you can also join on any attribute. You can force that join to occur. So I have a result set that now represents a join. Okay, I go in and I update some of that table, and now I split it apart. It's possible that I can't actually split the table back apart and realize data in the original tables. It simply can't be done. So you can generate result sets, which inherently are not updated. MySQL will know that. In fact, if you're working in the workbench, the other day when I showed all those workbench pictures, if you look down in the bottom of one of the result windows, there's a bunch of little icons down there, and one of them is a little, it's like a little pencil. You use a little, like a quill pen now, I forgot what they use, but it looks like a little pencil. If that's highlighted, that means you can update that result set. It's inherently breakable, partable, and updatable in the background. If it's not, that means the data you brought together is not, you cannot necessarily split it back and create the result in individual tables. MySQL will know that. Java does not. So you have to be very, very careful when you're doing those kind of things. So here's how you would set them. You set the result type, the result set type in forward only scrollable, scrolling insensitive back and forth, or scrolling only in the direction you scroll sensitive back and forth. You can also set it to be only read-only or updatable. The most common type to see is read-only and scroll sensitive. The problem with scroll sensitive is if you're looking at a very big piece of data, it doesn't even have to be that big a data set. I have an application. My Java application has just made a query. What I'm seeing now is the results of that query on my screen. The database is still live. Okay? Suppose that some other user somewhere else in the world has now changed some of that table that I'm viewing. I will not see that update, right? Because my results have been printed to me before their update occurred. Okay? This is another reason why if I make an update on my view of that and send it back to the database, it wouldn't necessarily be made. That update shouldn't be made. Suppose I'm looking at the value of 4. They just updated the value that I see of 4 and they made it 6. Okay? I update it and make it 3 and send it back to the database. What happened to their update? It's gone, right? And furthermore, there's no guarantee that my transaction is even going to survive. It might abort, in which case now when I abort, there's no way to even know that the transaction that made the update that should have stayed was even in existence. So the database at this point is now inconsistent and basically worthless. So we'll talk about these more, we'll talk about specifically what we do in the enterprise side of things, but again, keep in mind that to be safe, you want to make sure that they can update it, and often that they can only see, they can only scroll forward, which prevents changes that are being made in the back or behind them from being visible to them. Oh, this is just a couple of examples of how you actually change those values from the default when you create your statement option. So on your results, and you just specify what you want for that. So here's a slightly more complex example. It doesn't do a whole lot more than what we just did. So you see again the pattern here of loading the driver. All I'm doing here, this is a very common time thing, is I just set these strings static. As we get further and further, what we're going to generally do is we're going to have classes that do nothing more than load our applications. So we'll have all these parameters already predefined, and we'll just load them up instead of having to type them into the application. That way we can change configuration files basically and start with a different database, different user, whatever we want. So I kind of mimic that here, and instead of actually hard coding in the data here, I just used static strings to be able to do that. Same basic end result, but just a little bit different. So I'm going to iterate through, in this case I'm just going to grab everything from that bikes table, but now I'm going to start to get the metadata. Okay? So on the result set now, I'm going to actually use a get metadata method on the result set. I'm going to dump that into my result set metadata object. What's in here by default is all of the metadata for this table. Okay. Again, generally you don't use all of it, you're not even interested in all of it, but it's there, and now you can manipulate what you want. So one of the things that I'm going to get out of this one is, because in the previous example I said there were 3 attributes, I explicitly listed them. I could iterate through them because I knew there were 3 attributes per row. Now on this one, I don't. Okay, how many attributes are in this table? Well, again, if I know the schema of the table, I can know what that is, but in general, I wouldn't. So I have to actually find out, and one of the things that I'm going to ask the metadata is, what is the column count on this table? And then once I know that, I can, of course, use that in my loops to actually generate what I'm doing. And I just run through and get the metadata, so now I'm getting column names. This is all metadata. So it's basically the same end result that I'm going to see in this, but I had to add some extra steps to actually get that data printed out here. And then in the end, I simply close the statement, close the object, and we're done. And there's what you see now. So now the metadata is available to us, so we've used it at least to the extent of grabbing the column names as well as the number of columns in the table that we've got. Now again, we can skip columns. I happen to use it all in this case, but the fact that I queried all of the columns doesn't mean in my display that I have to view them all. I can use whatever I want. So it's there. I simply access what I want. Now, as we go, like I said, much deeper into this, we're going to really kind of have a disconnect between all of what we're doing on the database side and what our application is actually doing with that data. Commonly, when you think about enterprise solutions, it still mirrors what transactional databases most often do, in that probably 80% of your activity are queries. So we don't change the database in any way. But 20% roughly of those transactions do. They cause updates, they cause deletions, they cause insertions, that kind of thing to the tables. So when you start to make that disconnect, what you often want to see is a completely separate way, particularly Java, of viewing your results. And what I've done here is I created a more GUI-based application. All those 2 we've seen so far are just straight Java applications. You can run through command line, and they don't generate any kind of way for the user to realistically input data to say, here's the query that I want to run. So I'm going to have 2 classes now. One is the actual driver I call display query results, and the other is the result set table model. And essentially, I'm going to give that class all of the responsibility of handling the connection, generating the data, and so on. And all my driver class is simply going to do is either, it might provide some credentials for login or whatever, but it's basically going to just see the results. I'm just going to give you a window. In this case, a JTable. You can dump your results right into that. And that's what I'm going to use the results at table model to do. I'll put this code out on the website. It's fairly extensive. I probably shouldn't put it in the notes here, but you've got it here too. This is the class that's just handling the connection and the results. Okay, so all it does is do all that work. Here's where I've set the result set type. I changed it by default a little bit. I added some stuff about not being connected if you're giving me the wrong URL, because we now have that disconnect. So the information that's coming in from our GUI front end is where that login is going to occur. So the credentials have to be validated and that sort of thing. So it starts to get more expansive in terms of the error checking. And then I finally get to my driver class. This is basically just going to build a little GUI. Again, I use the same kind of technique of just creating some static strings here to handle all the input data. And then I put a default query in if the user just wants to come in and just test it without actually running the creating their own query. And so it'll run something in the background for them. And then we're going to have inside the scroll pane, we're going to have vertical and horizontal scroll bars, because we're going to fix the GUI size. But I have no idea how much data, width or height of data is going to come back from this. So the rest of it is just connecting to it. And this is now what it looks like. A much more robust application where I have a window for the user to simply type in their query. This one only is a query. Okay? And the reason it's a query is because right here, find it. method called set query. So this is where I'm actually executing the query. If the user is going to have the ability to send in an insert or an update or something like that, I've got to be able to detect what's coming in from them and switch this statement so that I'm not executing a query, but I'm executing an update. Because this will fail miserably if I ask to do an insert or an update. So this only works for a query. They can type their query in here, click the button, and this JSON table, JScroll pane is going to have their data displayed in it. This is scrollable and in this case not updatable. So that's the default query, and then there's a little bit different query run. You can see that the window updates. It's basically overwritten by whatever data is provided in the second or the next subsequent query that comes along. So this result set table model class that I created for you, like I said, I'll put that on the courses for you to use. It's a pretty versatile, generalized class for Java applications because it does all the connection handling, it deals with all of the results and the metadata, and you simply dump it back into any environment that you ask for. It's providing it basically as a JTable, so you can then deal with the JTable and dump it into any kind of GUI-based environment you want to use it. Now, the last thing I want to do today is show you one of the kind of statement, because mostly what we're going to be doing is we're going to provide the user a way to provide the actual statement or command to the SQL environment. But very often in data entry type situations, the user client has no SQL knowledge at all. I mean, you wouldn't get very far on Amazon if you wanted to buy a pair of shoes if you had to type in the SQL commands to do that, to modify the database. 99% of the world would not be able to issue those commands because Amazon would fail. So you can prepare a statement basically that's going to do that. And the prepared statement interface is in many ways like the normal statement interface. The difference is the command is already there, but it's parameterized. So the user doesn't have to actually input any SQL. You just ask them what color, what size, whatever the parameters for the command that you want to send to the database are. So in this case, I'm going to actually insert a new byte into the table. So I have to specify all of the, in general, I have to specify all of the attributes. There might be some default values in there that can be built into the database that I could omit default values if I wanted. But this essentially, when the statement is created, I don't know what those values are. So I generate them as placeholders, which the syntax for that is question marks. And then on the front end that I provide to the client, I'm going to have to actually ask them to send me the parameters. So I have setter and getter methods basically for these parameters. The only one that's really of interest, of course, is the set methods. So you specify the parameter index in that statement and the value that you want to send across. And then what you'll see in this case, for example, is here's where I generate the connection, here's the byte name, and so on. So my little version of this is you're going to ask the user for the byte that they want to see the cost of. Okay, so they're going to type in they're going to type in this. They're going to press the button to show the information, and what it's going to display back is just the cost. So in my parameterized statement here, what I generate basically is here is the query. The query string that I'm generating then is right here. I'm going to execute the query. I'm sorry, here. There's the parameterized one. So that question mark simply is taking that out of the form, filling that value in there, whatever the byte name they specify is, and then I execute the query, grab back the cost information, and print it out. This is the main method that drives it. So this is where I start separating things out a little bit. And that now is a prepared statement. So the user never entered any SQL like they did back here in this case. Here, it was all done for them and back. We'll pick this up and finish JTC next time, and then we'll start moving into servers where we actually use this in an application.